link to you, Laura. Link to you, Laura. Okay, we are on. Awesome. And let me get that. Okay. So, hi everyone. Thank you for tuning in to our third quarterfinals, our Erie Hack Buffalo quarterfinals, hosted by the Blackstone LaunchPad at the University of Buffalo. We will be hearing from 5 teams today on their ideas to solve some of Lake Erie's most pressing issues. Each team will be limited to 5 minutes to pitch their idea or innovation, followed by a 3-minute Q&A from our judges. And after we hear from all of the teams, the judges will deliberate privately to determine tonight's winners that will be advancing to the semifinals on November 4th. We've got a great panel of local judges with a wide range of expertise. But first, I want to thank our Erie Hack funders, partners, and supporters. Erie Hack is presented by the First Solar Community Giving Fund of the Greater Toledo Community Foundation and the Northeast Ohio Regional Sewer District, and supported by OHM Advisors. I also want to thank TechTown Detroit and Midstory in Toledo, and of course, the Blackstone LaunchPad at the University of Buffalo for all the work you've put in this year. And I'll go ahead and pass it now along to Derek.
Thank you, Felicia. Hello and welcome from the Queen City. So the birthplace of the grain silo, the chicken wing, and Rick James and the Google Dolls. And also, if you've been paying attention, we're making national headlines with our exciting mayoral race this year. Buffalo is located in the territory of the Haudenosaunee Confederacy. The Haudenosaunee have been living in harmony with the land and all that lives on it, and the water and everything living in it, generations before European explorers arrived here. We acknowledge the harm done by these settlers who took native lands and the untold numbers of native people who have been killed in the name of colonization. This region is still home to the sovereign nations of the Haudenosaunee people, and we are grateful for the opportunity to live, work, and share ideas in this territory. I'll post links in the chat on how you can learn more about the Haudenosaunee and the tactics to atone for the injustices enacted upon them. Our team here in Buffalo is comprised of Hadar Borden from Blackstone LaunchPad, Nate Dragg, who is the Great Lakes Specialist for the New York Sea Grant, and Ryan McPherson and myself from UB Sustainability, and we are excited to be part of the third Erie Hack competition. Our crew wants to thank everybody at the Cleveland Water Alliance that made this event possible. We've been incredibly impressed with their adaptability and efficiency in this iteration of the hack. I also want to thank all of our other partners, TechTown in Detroit, WEtech Alliance in Windsor, and Midstory in Toledo, and of course the generous funders at the First Solar Giving Community Fund of the Greater Toledo Community Foundation and the Northeast Ohio Regional Sewer District, and the support by OHM Advisors. I know that everyone tuning in has a special connection to water, but I really need to stress just how unique that connection is to Buffalo. Even the pathology of its name originates from the water system. When I first moved here over a decade ago, the story told to me was that French settlers saw the Niagara River and said, hey, that's a beau fleuve, and meaning beautiful river, and that's how the town found its name. Years later, the Erie Canal connected the east coast of New York to Lake Erie, the west coast. It makes it sound really hip if we call Buffalo the west coast, right? Which transformed our city to an important trade route. We also have one of the wonders of the world, Niagara Falls, 10 minutes away in our backyard. On a clear day, we can see its mist rise from our campus. But we all know that our region collectively is important. If extreme actions aren't taken, the Lake Erie watershed will become a refuge for people being displaced by the world's changing climate. We need to get our houses in order before that might happen. We need to make sure our water is clean and accessible to everyone, regardless of income or neighborhood location. We need to combat and prevent the detrimental impact of harmful algal blooms, and we need to modernize our infrastructure to make sure that it's resilient to increased pressures of demand and climate extremes. So that's why I personally love Erie Hack so much. Everyone competing has come up with a way to address those needs. The impacts of your ideas have so much potential for our region and quite honestly, our planet. I want to thank you for your passion and dedication to our lake, and best of luck to all the teams today. I'd like to introduce our judges. So if you could turn on your cameras just to be recognized briefly. Dr. Trevor Krabenhoff is an assistant professor in the Department of Biological Sciences at the University of Buffalo. His research on changing environments impact fish is incredibly impressive and applies very much to some of the topics today. Allison Leet is an environmental project assistant at the AMD Environmental Consultants and is a former Erie Hack contestant, so she knows this gig, right? And finally, Dr. Michael Shelley is an environmental and ecological economist, so many E's there, for UB Renew. And I've had the pleasure of collaborating with many times on many projects, and his economic focused mind is such a value add to all of our sustainability conversations. So I thank you all for your time and mentorship to our competing teams today. Alicia, with that, I'll turn that back over to you, and I'm excited to hear more.
Thanks, Derek. So now it's time to go ahead and get started. I would like to introduce our first team that is pitching, the Penn State Environmental Systems. And once I see them promoted to panelists, give me 1 second. Okay, we are in the process of promoting the team to panelists. And once that happens, I will get my timer ready, make sure you have your camera on and your mic on, and go ahead and share that screen of yours. And then we'll go from there. Riley, how are you doing?
We're doing well. Madhav, are you able to share screen? One moment, please.
Awesome. Remember to have your cameras on, to have your mics on. And y'all have presented. Okay. So once you start presenting, I will start my timer. And whenever you're ready.
I think we're just waiting on one other person. I think they're in here underneath my name, but whenever I get that all clear, I'll start.
Okay, sounds good.
All right, so I guess we can begin. Good afternoon, everybody. We are Penn State Society of Environmental Systems Engineers, and today we will be presenting our topic on eutrophication, a biochar solution. Algal blooms have threatened the lake's ecosystem for decades. As fertilizers and industries continue to pollute our lakes, we must find new ways to reduce our impact. This leads to our problem statement. By adding biochar to various regions of the lake, we are able to lower nutrient levels and reuse the mass for fertilizers. What is biochar? Well, biochar is a black carbon produced from biomass sources. It uses carbon sequestration to remove nutrients. How does this work? Well, biochar has a high adsorption density and rate that helps remove nitrates and phosphates, as well as heavy metals from water, which is done through adsorption and ion exchange. For our project, we will be researching how biochar works in removing nutrients from shallow bodies of water. We aim to study the effectiveness of biochar in removing pollutants through various stimulants. These factors include the pH of the water, the temperature, and coexisting ions. All of these are independent variables that affect the adsorption capacity and effectiveness of the biochar.
How does this help Lake Erie? At the lab scale, it has been shown that biochar is effective to remove phosphates and nitrates from water and wastewater. We will use this capability of biochar to remove phosphates and nitrates from contaminated flows which are flowing into the lake. This removal will help us in reducing the phosphate and nitrate load that enters the lake, which will allow the lake to heal itself since the nutrient load will no longer cause excessive algal growth. At some point, nitrate and phosphate removal capacity will reach a maximum. So we will replace the biochar with pristine biochar. But the used up biochar can be used for fertilizer since it contains phosphates and nitrates. We will reuse this biochar as a fertilizer since it has been shown that, since research has been shown that biochar releases phosphates and nitrates slowly to enrich the soil. Also, they help in improving the moisture retention capacity of the soil. Research has shown that biochar has improved crop yield by up to 25%. Hence, with this approach, we do not have to worry about the safe disposal of biochar.
For our action plan, we will first use contour maps and hydrological data to identify the Lake Erie watershed and the various entry points for runoff. Literature data, along with on-site sampling, will provide us the phosphate and nitrate load from these points. We can then design treatment plans at these entry points based on this data. We will use probes to measure the influent and effluent concentration of phosphate and nitrate. A system of online monitoring of the influent and effluent will be developed, which will help us in keeping track of multiple plants from a central control location. Finally, to reduce the cost of biochar, we will use locally available agricultural waste to produce biochar. In essence, our solution uses waste to solve the issue of phosphate and nitrate, and then uses these nutrients to enrich the local soil. Thank you.
Thank you. If judges could now turn on their cameras, unmute their mics, and start asking their questions.
Okay, I'll go first if I may. So with this scheme, you're basically using agricultural waste to generate biochar. And then it sounds like you're going to use that as some sort of filtering medium for stormwater. Capture the nutrients, return the biochar to the fields. Is that the essence of it?
Yeah.
Okay. So now you just mentioned that the biochar increases crop yields. Mm-hmm.
Yes.
And since non-point source pollution is really hard to tackle, have you considered perhaps taking the crop waste, turning it to biochar and returning it to the farmland and capturing those nutrients and keeping them in situ?
Well, so it will create a feedback loop, right? If I understand you correctly, you're saying that likely use the biochar as a fertilizer.
Well, what I'm saying is one of the biggest sources of nutrient inflows into the lakes is from some called non-point sources, which is agricultural, right?
Yep. Yep.
So if you use a waste product to generate the soil amendment that's useful to the farmers, then you might have a better commercial model, right? Because you might be able to sell them that and why would they pay you? Because it improves their crop yields. And also you would be capturing some of that non-point source pollution, which has been proved so difficult. That's I wondered if you considered something like that.
Oh yeah. So the point here is this is trying to capture those non-point sources through identifying where are the the non-point source will converge and they will have entry points. There will be multiple entry points into the lake. But if you can identify which entry points have the highest flow and the largest concentration, then we will use that. The agriculture side part can work, but for that you need to reach a point where the biochar is able to replace the conventional NPK fertilizer, right? And I don't think
not really, because if there wouldn't be any runoff if the fertilizer was getting utilized by the plants, right? So what you're trying to do is capture the part that the plants. So what you're doing is you put a load of fertilizer on. The plants get it 1 year. The bits they miss goes into your biochar, and they get it the next year as it slowly releases. To make a more effective use of the fertilizer.
Yeah, that can work. That can also work.
Okay.
But I would say the problem there might be the amount of biochar required. Right? At some point, it would be like the fraction would be 60% soil and 40% biochar or something like that. I don't know. I'm not thought about it, but that's a good idea.
Well, every little helps, right? And it's a cumulative process. There's always agricultural waste at the end of every year.
Yeah. That.
I have a question as well. So you mentioned you want to work locally, and you also talk about agricultural waste. So I'm kind of wondering how you might go about reaching out to local communities and utilizing agricultural waste within something like Cattaraugus Creek watershed, which we know is experiencing harmful algae blooms and this eutrophication problem.
So in a way, they need to get rid of water. The agricultural waste, which is something like unused part of the plant. For example, in corn, there are some unused parts. Those kind of biomass we can use, and we are just taking them off their hand and using it for something else, and they don't have to worry about what to do with those. So I think it should be pretty feasible for them, and we can make a connection that instead of taking it for free, we will give them the biochar at some make it a circle, make it a kind of circular economy where they are giving us a waste and they are getting a product which has value in it.
Right. Okay. Thank you.
Awesome. Thank you. I think that is all the time we have for questions. If we can get the next team up and queued up and ready for their presentation.
Thank you.
Thank you.
You all.
Thank you.
Thank you.
Okay, next up, we have DAMPR. So if you could turn on your screen, unmute your mic, share your screen, and hit the present button. And when you're ready, I will start my timer.
Hey, we are Team DAMPR. Good afternoon, everyone. It's device for active microplastics removal. I'm Dr. Varun Kasaraneni, and our core team is listed there. A group of us students standing right behind me. They're all from Gannon University. Microplastics are pollutants of increasing concern in Lake Erie and Great Lakes and several other water bodies around the world. The presence of microplastics harm aquatic life, birds, and result in poor water quality. Further, microplastics contaminate food supplies, act as reservoirs and carriers of other hazardous pollutants into ecosystems and humans. Studies have shown that Lake Erie has the highest concentration of microplastics among the Great Lakes. Further, if we look at the size analysis, the study on the top here circled, you could see a large fraction of these microplastics are under 2 millimeters in size. That's the same case in several other water bodies around the world. Currently, there are no technologies or devices available to remove microplastics from surface water bodies such as lakes. Our solution is DAMPR. DAMPR is a device that could effectively separate and collect microplastics in the size range between 280 microns to 3 millimeters. That could be done in lake waters and other surface water bodies. And the device could separate microplastics from the surface of the water to below 2 feet below the surface. DAMPR can be programmable. So the separation parameters could be changed for various size ranges that we want to collect, and also operation times based on the charge availability in the batteries and during how long during the daytime you want the system to be operational. We're confident that the separation mechanism will have minimal or no impact on aquatic life and plankton. So the system will have a self-cleaning mechanism that could be pre-programmed. So any life forms that enter into the system will be discharged into the lake back with no harm to the life forms. As the dimensions indicate, DAMPR will be portable enough. It could be easily transported and relocated to different locations. Some of the other features that will be included in the system will have solar panels and lithium-ion batteries, and the system will have flotation and anchoring mechanisms. So it doesn't have to be in a particular location. It could be deployed offshore, near shore, or any other multiple locations. We'll have sensors at different levels, so we could detect any clogging issues and also when the system reaches the maximum capacity. We'll have internet capability, 4G antennas, so alerts could be sent to your mobile via text or emails when the system experiences any issues. We'll have GPS tracking and beacon lights, so the system is always visible physically, and also you could track in case if the system anchoring doesn't work. The current version being developed is a portable nearshore version, but this could be easily scaled up for offshore, which will be a little larger device. Some of the steps, future steps and budgetary allocations are as follows. This is our plan. So we want to finalize the design and have the prototypes built by March 2022. We'll do extensive lab testing first, and then any modification that needs to be done will be conducted. And then an extensive field testing in Presque Isle Bay in Lake Erie will be conducted during the summer of 2023. And we'll perform a system analysis, and any modifications will be conducted, and field testing again a second round. And we hope to have a final design of DAMPR system by August 2023, and also a manual that could help users. Our implementation, right now we are planning for a local level implementation with few devices deployed in Lake Erie, part of Pennsylvania. Our partners during the development and testing phase currently include Gannon University, different programs, aquatic marine biology, mechanical, electrical engineering, computer and information science departments. During the testing and small scale implementation phase, we have Regional Science Consortium at Tom Ridge Environmental Center as our partner, and we're open for large scale implementation partnerships. These are some of the references. Thank you for your time, and we're happy to answer any questions.
Thank you, DAMPR. If the judges could now turn on their cameras, unmute their mics, and start asking their questions.
I actually don't have any questions. That was a very commendable, that was a very good presentation. I actually feel very well informed about the product.
Thank you.
I was wondering if I could ask about, I'm interested in this, how you might separate the life part from the plastic part, and also just particulate matter in the water as well.
So I don't know how much details we could give. We haven't patented the systems, and you have to sign NDAs for me to give all the details, but it's based on simply the settling velocities of particles, the densities of plastics and densities of plankton and other life forms. The system will have some a size limitation where when the water is coming into the system, anything larger than 5 millimeters will not be entering the system. Anything that's smaller than that, that's different life forms, in our theoretical calculations, we expect those things to be separated. That's how much details I could give right now, but I'll be happy to share something in a personal conversation.
Thank you.
Quick question, approximately how much or what volume or surface area of water will this process in say a year?
In a year, we haven't done that calculation, but our flow rates, we're expecting about 5 gallons per minute. Around 5 gallons per minute. So, and depending on the energy availability, like how much charge batteries could gain during the daytime, it could run anywhere between 6 to 8 hours per day at 5 gallons per minute. So
what's its zone of influence? I mean, what if I put one in a portion of the lake? What area will I clean?
That's something we haven't been able to calculate yet. That's something we'll figure out once we do some field testing. We will know.
Okay.
As of now, we don't have an answer.
Okay. And then, have you, from the research that you've looked at, are there certain areas where the microplastics congregate? I mean, because I assume you're not going to just or do you have to randomly drop them around the lake, or there are certain places?
There are certain locations currently. I mean, with the region that we are in, close to Pennsylvania, part of Lake Erie, we are familiar with certain locations where we see a lot of microplastics.
Okay.
So people that purchase these devices or want to implement these devices on a large scale, we could definitely do some sampling and figure out where there are larger concentrations of microplastics. It's especially if you have a loading dock or a marina, you do see a lot of waste there, litter floating around, and those are good places to start.
Okay, and then just a practical thing, you might want to consider making sure they can withstand ice.
Yes, so the current plan is to have them deployed between April and October, end of October, and we want to take them out. Because in winter, even if the structure is stable, the batteries might not last.
Yep, yeah, I was going to ask you that. Okay.
All right, that is all the time we have for questions. As we get ready for the next pitch, if judges could please enter their scores from the previous 2 pitches, and we'll give it a minute or 2. While we start queuing up, let's float some sensors on the lake.
Sorry about that. Forgot to turn my mic on. All right, so let me share that again.
No worries. If you could give it another minute anyways.
Oh, okay.
That way judges can catch up with.
No worries.
So honestly, it was a great thing that your mic wasn't on.
Oh, perfect.
All right, judges, are you ready? If you could give me,
Yes.
okay, awesome.
Yes.
Okay, I think we can go ahead and get started. So whenever you start, I will start my timer.
So is my screen, is everything looking okay?
This looks perfect.
Okay. So my name is George Hampton, team Let's Float Some Sensors on the Lake. And I just want to point out, first of all, this picture I actually took on Lake Erie. And I love the idea that we can see the sunset over water and we don't live on the West Coast. Some of us along the lakes have this. Also, I've been, Derek spoke of his love for the lake. I've lived within a mile of the Niagara River my entire life. And now I'm pretty close to the lake. The river's that way, about half a mile, and the lake's maybe even a mile that way. But anyway, let me not waste any more time on that. So I'm not so much into the biological aspects, but I'm a technician, electronics and computer science guy. And so I was thinking originally that I would build a floating sensor, buoy sensor that you could drift down the lake, put it in Detroit and it would, you could pick it up in Buffalo. And then I thought, oh, this is going to be difficult to retrieve them. So why don't I make it light enough that a drone can pick it up? So I ended up having a meeting with one of the mentors, Mark Epp, and he liked the idea of the drone deployment, but he said even for fixed buoys, this makes sense. So I focused on that. And the strategy is to build a very lightweight buoy with heavy lift drone transport. And some of the benefits of this are ease of regular maintenance. These sensors, some of them require monthly maintenance, and it costs money to rent the boat and go get them and bring them in. And with the drone, that would be easier. Also, it could extend the season. Apparently, they're very soon going to send a boat out to retrieve the buoys, and they have to do that a little bit early because you have to schedule that ahead of time, and you don't know what the weather's going to be like. So you might be able to get another expansion of the season. And the whole lake we could cover, the drone range, if not now, maybe a year from now, we'll be able to cover any place on the lake, assuming you're going in from both the US and Canada. And also it may reduce costs, depending on the cost of the buoy or service, but that's a consideration. So I looked into heavy lift drones, and I didn't do a wide survey, but there's a company called Griff Aviation that currently has a drone that will carry 35 kilograms for half an hour, which is impressive. And next year they'll have one, as you can see, 150 kilograms for 45 minutes. And then scheduling out, they're talking, real industrial applications. So this won't mean carrying multiple drones. That means the range will be longer. We'll be able to carry 10 or 20 kilograms, maybe 150 miles or something like that. I mean, kilometers. So the buoy itself would be made of the enclosure, a platform, tether, and anchor, which I'll describe a little bit, the electronics, the solar panels, and the sensors. And I'm an electronics guy, so these are the ones I know about, but the others I've done a little bit of research into. So this is what the buoy, initial design. It doesn't need to be big because the electronics and the sensors for, sensing things in the water aren't very big nor heavy. So something small like this. And then, here's a high-tech moment. Just have to do this. Oh, I can't do it through Zoom. Whoops. Yeah, this is a video, but apparently it's not working. That was my high-tech moment. So the tether, a lot of buoys are tethered like this. So my idea for this is we don't need the weight of the chain, and to put on the tether a platform that the drone can drop the the buoy into, and then with the mechanism lock it there. And then when it picks it up, unlock it and pick it up and take it off. So this would need to be installed wherever the buoys were going to be deployed, but that could very likely stay in the water all season since it could be built really ruggedly. Whoops. So the enclosure, I did a little research. I'm not a mechanical engineer, but I looked into lightweight things, and the carbon fiber composites are very light. And I found one that, like I said, is less, about a little over half pound per square foot. So we can build that mechanism. I'll get into that later. Oh no, that's right. The dimensions of the outside of the shell of that is 8¼ square feet. So it's the enclosure itself is 5 pounds, which is nice. And then the extra stuff around it, seals, the hard nuts and bolts, the retrieval hook, and the connector mechanism, that adds up. Well, there's totals at the end, but weight is a huge concern here.
But that is the 5-minute mark, and I unfortunately have all time now. So if the judges could now turn on their cameras, unmute their mics, and start asking their questions.
George, I guess I just have some general questions for you. Like, what brought you into this? What's your idea behind having these remote sensing buoys with the ability to have the drones? Did you have target areas? Do you have target things you're looking to have surveyed? I'm just wondering where you're generally coming from. And I know your background is an engineer, but I want to know kind of why you're interested in creating this.
Well, part of it is, applying my engineering talents to things good in the world, which I'm trying to do. And the other thing, this is kind of interesting. There was a art patron in Buffalo who some years ago, he has a celebration in the spring called Boom Days, and he wanted to float something down the river where he could track it in real time, or down the lake through the river for this event. And I had talked to him a few years ago about it. And then another reason is I learned, I didn't get to the electronics, but there's a company called Blues Wireless, which the electronics, the details here. Let me just add, the one thing I didn't get to is the whole thing comes in at around 10 kilograms. So with the drones and a 10 kilogram buoy, there's a lot of range. But anyway, Blues Wireless, I saw a webinar where one of the guys who works there did a environmental sensor platform for a river in, I think it was Missouri. And their products are really good. I'm using them for other things. They cover the wireless modem, the cellular modem and the electronics, and it's really light and cheap. And I'm excited to get that. So, love of the river, being able to do something. And, originally it was a floating idea, but when I talked to Mark, the idea that, using this transport mechanism rather than boats made a lot of sense. That's
especially cost effectively. You made it seem.
Yeah,
yes.
yeah. And I should have timed that better. I knew I talked too much.
So, George, just one quick thing. How are you going to find them?
How are you going to find? Oh, they have GPS.
So will they send out a signal says drone come get me?
If for the floating ones, yes, but for the fixed ones, you'll know where they are. But there's GPS on it. You can monitor it at all times. Basically, it's got a cellular modem, so you can gather data constantly, and along with the GPS information, so you can know where it is and everything about the sensors. So you can determine by lake conditions when you need to get them. But mainly, I think the big thing is that they need regular maintenance. The sensors need recalibration fairly often. So being able to retrieve them, either replace it with another one right away or service it and put it back.
Right.
But you could actually, in a round trip, no, I guess you'd need 2 trips because you need to lift one out to put the other one in.
Right.
So I think, as far as that goes, it'll be a pretty good solution. The sensors are the standard sensors you would use in the buoy, are already being used in buoys that are currently on the lake.
Yeah.
And they're very light as well.
Yeah.
Can I jump in with a quick one? I was just wondering about boat safety and how boats might avoid these things out on the water.
I guess that would be, the floating ones, that isn't the main, or the drifting ones, I don't know. And I don't know really that much about current deployments, but there are buoys in the lake now that are doing this, there are sensors. So however that is handled now as far as, the marine safety goes, whatever standard practices are in place, that would be the way to do it.
Awesome. Thank you, George. We are now going to take a 5-minute break. So if judges and everyone could turn off their cameras, turn off their mics, and we will meet back here at 1:47. This gives judges some time to update their sheets and to get ready for the next one and to take that break that we might need. All right, I will see y'all back in 5 minutes.
Hold me close till I get up. Time is barely on our side.
All right, welcome back, everyone. If the judges could turn on their cameras just to let me know that they are all here. I will give it another minute. Oh, there is Michael. Okay, thank you. Feel free to turn cameras off. I see that we have Blue Lion Labs queued up and ready. And so just as a reminder, have your camera turned on, unmute your mic, share your screen and hit the present button. And whenever you are ready, I can go ahead and start my timer.
Test, test. Can you hear me? And I'm ready to go whenever. Okay. Hey everyone, I'm Jason, the CEO of Blue Lion Labs. And I want to ask you a question. What was the first thing you did after you woke up this morning? Well, maybe you had a cup of coffee, you probably brushed your teeth or had a shower. Well, I bet that within the first hour of your day, you use water. Now I want you to imagine that the water you drink from your tap is not clean or safe to drink, but that it has invisible toxins. These toxins produced from a harmful algae bloom. But what exactly is a harmful algae bloom? Well, harmful algal blooms happen when different types of cyanobacteria grow out of control. They can produce different types of toxins, like hepatotoxins or neurotoxins, causing damage to our liver or nervous system, and they can even be fatal in certain situations. But these harmful algal blooms are not just affecting our drinking water. They're affecting our recreational use of water, as well as the fishing industry. It's estimated that the US spends around $4.6 billion a year dealing with blooms, and China around $6.5 billion a year. And with climate change, these blooms are only expected to get worse. So what do you do if you're an operator at a drinking water treatment plant and you have a harmful algal bloom? You have to take a water sample, ship that to a lab, and then the staff at the lab analyze that water sample with expensive equipment to determine the type and concentration of the toxins. This process normally takes a number of days. And what this means is that the water treatment plant is in a reactive mode. They're making reactive decision making. The three main types of analytical methods to determine the type and concentration of toxins are LC-MS, HPLC, and ELISA. What we've done is we've built off the ELISA assay. We've built a low-cost microfluidic chip that takes in a water sample that has toxins, as well as microbeads, combines those, and then images the microbeads to determine the concentration of the toxins in the sample. We've built a lab prototype and tested it on MCLR, the main toxin regulated by the US EPA. So on the left, you can see our microfluidic chip. What's happening is we're taking in both MCLR toxin in water as well as microbeads, and these are then mixed. They're then accumulated and then put under a microscope. And that's what you see on the right. You see these beads fluorescing based on the concentration of the toxin in the sample. The benefits of using a microfluidic chip is it allows on-site testing, as well as real-time analysis. This means the water sample doesn't need to leave the premise of a water utility. This is really important because this enables proactive decision-making for the staff at the water treatment plant. Just imagine being a water treatment plant operator and knowing the results in a number of hours, opposed to waiting days. The team is 4 of us. So on campus, we have Dr. Malik Budina, who's leading a microfluidic chip lab, and she's an alum of Stanford. Hamid is working on this for his full-time for his master's, and he's an expert in microfluidics and chemistry. This work is supported and funded by Blue Lion Labs, and Blue Lion was co-founded by Katie and myself. Katie is the COO, and she's a world-renowned expert in harmful algal blooms, and is a professional algal taxonomist, and I have a PhD in machine learning and data analysis. In order to take this tech to market, we're going to use Blue Lion Labs' existing infrastructure to support bringing this toxin chip to market. Currently, we're building a monitoring tool to determine types of organisms and algae in the water, and we can use our network connections and resources to build this toxin chip and bring it to water utilities. We need these funds to get our lab testing instrument into the real world. And we already have one water utility here in Canada, where we're based, who's eager to test our chip. We just need to finish a few more results in the lab. So we're Blue Line Labs. We believe that everyone deserves to know if their water is clean and safe to drink. Thank you.
Thank you, Blue Lion Labs. If the judges could now turn on their cameras, unmute their mics, and start asking their questions.
I do have a question, just because I'm a bit unfamiliar with some of the terms that you used. ELISA, you spoke of you're building off of ELISA, and I'd like to know exactly what that, if you could build on what that is a little bit, and what the relationship between your project and building off of this other project is.
For sure. I'm going to let Hamid take that question first, and Katie might have some comments as well. But yeah, essentially it's pronounced ELISA, although it could be read as ELISA, it's fine. But it's essentially a chemical assay that people use to determine the concentration. Maybe Hamid, if you can expand on that.
Okay.
Yeah, for sure. So basically this ELISA is immunoassay. It's a reaction happening between biomolecules. And what we want to do, we want to capture toxin with this reaction. And the product of this reaction is this fluorescence signal. So basically, we are using this immunoreaction to determine toxin concentration.
Okay.
Yeah, and I'll build on what Jason and Hamid have said, in that the ELISA test is what is being currently accepted as a as part of the regulation. So it's a regulated accepted method of measuring microcystin in water. So that's why we're using that to build off of.
Okay, thank you. That clarifies a lot for me. Appreciate it.
Going back to one of the other presentations, and the idea there, could you deploy this in a mobile sense? Because it's not just at the water treatment plants, you want to know where the algae is, right? Because can you put this out in the lakes in some way?
Mm-hmm. So initially, no, but long term, yes. It really depends on how well the technology works. Initially, it's going to be based off of a cartridge. So it's essentially like a dump stick that you might have 1 or 2, 3 tests that you can run on. And so to deploy it remotely in the field would be challenging. And that's why we're essentially doing it on site. Long term, as the technology evolves, it definitely could go into something that could be completely remote. I think more work would have to be done to fully accomplish that at scale. Hamid or Katie, I don't know if you have any comments on that.
I think you covered it.
Yeah.
So you've got 2 bits to your system, I'm thinking. You've got the bit where basically you put the water in with the beads and the beads absorb. And then you got the second bit, which is a readout. So if you were to separate those 2 parts and have the collection part go out into the lake, then you could do the readout when you get back, right? That's rather than having necessarily having an integrated device. See what I'm saying?
Mm-hmm. Yeah, you could separate the 2. Yeah, that is something for sure that we could explore.
It's I was just wondering, the MCLR, so that part of it, is that exist with current ELISA technology, or could you speak to the specificity aspect of it?
Sure. So just so everyone understands, so MCLR is a type of toxin that's regulated by the US EPA. I would say most standards that I'm aware of use MCLR as a baseline. And so what exactly is your question, Trevor?
Sorry, I guess I was wondering about specificity, if you have any sense of.
Yeah, Hamid, could you comment on that?
Yeah. So by specificity, you mean the concentration of the MCLR that are out there and we want to sense? Did I get it right? Sorry, you cannot hear me?
Sorry, I missed it. Yeah.
Yeah. So by specificity, you mean the concentration of toxin that we can sense in the water?
Yes, or off target, similar types of chemicals, but maybe not exactly what you're looking for.
Yeah, so there's a regulation developed by World Health Organization about the minimum concentration of MCLR I mean, above that is unsafe for drinking water. Our primary target is to have that sensing. I mean, our device would be able to sense that amount of concentration of the toxin in the water. So that is our goal. And the further step, we will go lower than that to make sure that the water is totally safe for long-term drinking.
What's the exact measurement that we're using as the lowest threshold that we can measure as a target? And what do you know of the US EPA regulation offhand?
Yeah, I think it was 1 microgram per liter is the minimum dosage of the MCLR concentration in the water.
Yeah, and I think we're doing a factor of 10 lower, is that correct?
Yeah, 10 lower.
Yeah.
All right, thank you for your questions, judges. We're gonna wait a minute or two as you fill out your sheets. Thank you, Blue Lion Labs, for your presentation. And we will queue up our next team, Quantum Aerial. If you could go ahead and start sharing your screen, we'll just give the judges a few more minutes before I give you the heads up to start. India, just an FYI, the presentation is currently on like present mode where we can see your notes as well. Not sure if you're okay with that, up to you.
One moment, I'm gonna try to fix that. I have 2 screens, so it gets a little odd.
No worries.
Let's try this. Can you see the presentation now?
Yes, but we can also still see your notes.
Oh gosh. Now?
Are you
still see
sharing
the
your-
notes?
Are you sharing your screen?
I am.
Could you try and share again? Okay, now it's good. And just as a reminder, have your camera on, and I will get started as soon as you start.
Can you see me?
Mm-hmm. Right, awesome.
And let me pull up the other screen. And I am all set. Hello, my name is India Johnson, and I am the CEO of UAVistas. My team is Quantum Aerial, and this project focuses on automated invasive species detection in wetlands. So let's frame the problem. Lake Erie has faced many challenges over the years. One of the major ones being harmful algal blooms, or HABs. HABs are primarily caused by too much nitrogen and phosphorus in the water. So how do the nutrients get there? Mostly from runoff caused by flooding and from sewage. Now on to one of the solutions, wetlands. Wetlands provide many ecosystem services, including but not limited to providing vital habitat for native species, storing carbon, and very importantly for Lake Erie, purifying and storing water. This is why many organizations, as well as the H2 Ohio initiative, have focused on bringing wetlands back. Creating more wetland area around Ohio watersheds will help prevent the flooding that can cause runoff of nutrients and sewer overflow into Lake Erie. These wetlands can also store nutrients such as nitrogen and phosphorus, and provide many other ecosystem benefits, as you can see here. But there's a problem that wetlands face that can inhibit their effectiveness or even destroy them altogether if left unchecked: invasive plants. Invasive plants can reduce the ability of native plants to grow in a wetland, of native animals to settle there, and even reduce the ecological service capacity of the wetlands. In addition to invasive species being an issue, tracking changes in the general health of a wetland over time can be a challenge. How do we monitor the wetlands that are created? How about existing wetlands? How do we determine if they are healthy and functioning as they should and not overrun with harmful plants? Our solution for dealing with invasive plants and making the assessment and management of wetlands far easier is to use drones to automatically detect and map the things in wetlands that aren't supposed to be there, and gauge the overall health of a wetland. With the H2 Ohio initiative alone, planning to create or restore over 50 wetlands in Ohio, a fast and effective way of assessing them and tracking changes in invasive plants will be necessary. Being able to generate data that gauges the progression and health of a wetland over time will be essential for future planning and management. So how do we plan to do all of this with drones? We plan to use several layers of data to train machine learning algorithms to detect and identify invasive species in wetlands automatically. Frequently, multispectral and hyperspectral imagery are used to determine plant health in agriculture. So why not apply similar technology to assessing wetland health and mapping invasives? On the left is an illustration of how plant health is determined with spectroscopy. On the right is an image of a plant under UV light. As an aside, many animals such as butterflies, bees, reindeer, and some birds can see in UV and glean information from their environment by doing so. So why can't we do something similar? A plant's health, function, and type can alter how light is reflected off of it. This is key to more accurately identifying them from the air, engaging wetland health and efficacy. On to market analysis. According to the USGS, the U.S. Geological Survey, there are about 483,000 acres of wetland in Ohio. Not all are managed, of course, and acreages change over time, but this is the number I use as a rough estimate. 482,000 acres at $10 an acre to fly twice a year creates a market of 9.6 million in Ohio alone. This may be a conservative estimate given that the average cost of flying an acre of forest with a drone is between $15 and $20 an acre, bringing us to a high estimate of $9.3 million just looking at wetlands in Ohio twice a year, and just over 38 million if checking seasonally. And note, this doesn't include wetlands that are being or will be built. In terms of funding, I've had my project pitch accepted by the National Science Foundation SBIR program and are currently working on building a full proposal. Pursuing USDA and EPA SBIRs is also an option, as are other grant funding opportunities and self-funding through my business. In terms of growth, there will be a great deal of opportunity. Wetlands aren't just in Ohio, neither are the large bodies of water affected by them. Seasonal and yearly tracking via subscription-based model creates consistent income and regular clients. Hiring broadly to cover a wider area and create employment opportunities expands our market as is increasing the number of services provided. This is the Quantum Aerial team. It consists of me as team lead, Natalie is our machine learning specialist, and Matthew is our data analyst. That is the end of my pitch. Thank you for your time.
Thank you, India. If the judges could now turn on their cameras, unmute their mics, and start asking their questions.
Yeah, thank you. I was just wondering if, does the vegetation need to be emergent? Does it need to be out of the water, or can this go through?
Currently, we're looking at plants above the water. There's usually issues with trying to detect things underwater because of the unique properties of water. There's been some success with it, but it's very experimental. So I don't really know how well it would be able to detect plants under the water.
Okay, thank you. Sorry if I missed that bit of it. Yeah.
So do you have any indication of if this would be more cost effective than, I know, because I have a friend who does wetland delineation for a company here in Buffalo, and having someone out on the ground doing those surveys versus using the drone, I mean, the cost projections you presented are pretty hefty. So I'm just wondering if you've looked at the difference between the two, given that these delineations are already occurring in invasive species and whatnot are being assessed already.
So I don't know how much it costs to put a person on the ground on a regular basis to assess these, but the benefit of using a drone is being able to look at a larger area quickly and being able to take in a lot of data at once and process it. And then with machine learning algorithms, you can get into predictive analysis. So it's kind of like getting an overview of a very large area, sort of like what they do with some satellite imagery, especially in areas where things may be overgrown, where it may be dangerous, where there may be alligators. So looking at safety and convenience sort of helps. It's the idea behind using a drone as opposed to people all the time anyway.
Right. I guess I hadn't considered those perspectives. Thank you.
Hi, India. I have a quick question. So you're going to use hyperspectral imagery, which is going to get you a sense of how, as you demonstrated, how well the plants are growing, really. So you're really going to pick up on plant health. But how are you going to use that to distinguish healthy native species from healthy invasive species?
So the idea is to have multiple layers of data in the algorithm. So we would use RGB data, and we would take in the regular visual imagery to identify plants as well as possible from that. And then the multispectral and hyperspectral imagery has two uses. So one is to aid in identification. So it adds an extra layer of data to help distinguish the native plants from the invasive plants. And it can also be used to assess plant health. So that sort of imagery does two jobs.
Right. So if you had a go at using on the ground, at least using your imagery to tell the difference between one type of species and another?
I have done some tests just this month, actually. And right now we're still parsing through the data to see if it looks different. The native species look different from the invasive species. There are some differences in plants that tend to be very bright or stand out more, like pokeweed and what is it called? It is tree of heaven. But actually determining whether or not a machine learning algorithm can say, hey, I got this data, I'm going to separate it myself. We're still testing.
All right, thank you, India, and thank you, judges. If all judges could now turn off their cameras and unmute their mics and start transitioning into our Google Meet, the judges deliberation room. And just for everybody else that is still here, we will be announcing the semifinalists, those that are advancing to semifinals, once we get back from the judges deliberation room. Thank you. Hi, everyone. So as the judges start making their way back, we will start announcing the semifinalists that advance from today's quarterfinals. So while they're making their way back, I would like to reintroduce Derek to announce which teams will be advancing.
Thank you, Felicia. You can hear me okay, right?
Yes.
Okay, thank you. Thanks to Felicia, and thank you to all of our participating teams. Whether you're moving on or not, on behalf of all of us, we strongly encourage you to continue pursuing your innovative and entrepreneurial journeys. We look forward to following along with you. I'd like to share that we're actually going to advance 4 teams to the regional semifinals on November 4th. Those 4 teams are Team Penn State Environmental Systems with their method of removing pollutants from water with biochar, Team DAMPR with their microplastic separation technology, Team Let's Float Some Sensors on the Lake with their GPS-based data collection initiative. And then the last team moving forward is Team Blue Line Labs and their microfluidic chip for toxin detection. The winning teams will have an opportunity to continue competing and earning prize dollars and support services. So regardless of the outcome, please, we encourage you all to keep in touch to get our support and to further share resources. Those of you advancing, Felicia will be reaching out directly to coordinate next steps, and we're looking forward to seeing you again on the semifinals on November 4th. I'll turn it back over to Felicia to close us out.
And thank you again to all participants for your hard work. And of course, to our judges for volunteering your time to hear all of these incredible pitches. As mentioned, I will reach out with more information as well as the next steps. So I'd like to invite you all to our very last quarterfinals this upcoming Thursday as well at 2 p.m. and that will be hosted by Midstory. Thank you again and enjoy the rest